Attention naval marvel fans. This amazing inside look is at the USS Gerald R Ford, one of the world's most powerful battleships. Join us as we explore this modern naval engineering marvel's technological, strategic, and high-speed movements. USS Gerald R Ford, Powerhouse. USS Gerald R Ford is a marine marvel of modern engineering and technology. Power and length of 400 meters dominate the seascape. Its unmatched sophistication and capacity outweigh its terrifying bulk. The USS Gerald R Ford has cutting-edge technology that revolutionizes naval warfare. The EMALS catapult mechanism replaces steam-powered launch systems, a significant invention. The unprecedented electromagnetic energy-based aircraft launch precision and efficiency of EMALS reduce aircraft and crew stress. The cutting-edge airplane recovery technology, Advanced Arresting Gear, AAG, complements EMALS. AAG uses energy-absorbing technology instead of hydraulic arresting gear to land planes safely. This improves operational efficiency and reduces aircraft and carrier infrastructure wear. Propulsion, combat, and radar systems on the USS Gerald R Ford are advanced. The carrier's maritime fighting capabilities, situational awareness, and survivability rate have improved with these enhancements. In addition to its technology, the USS Gerald R Ford symbolizes American naval superiority. It symbolizes the nation's determination to remain the world's foremost naval force. It represents the U.S.'s determination to protect its interests, deter aggressors, and sustain world peace and security as a strategic asset. The USS Gerald R Ford epitomizes naval engineering and creativity. 2. Strategic need. Fast naval maneuvers. High-speed spins help naval boats like the USS Gerald R Ford escape danger and traverse dangerous conditions. In the unpredictable maritime environment, quick, decisive turns at high speeds are crucial. The Navy uses high-speed spins for tactical avoidance. Due to their value, opponents may want to disable naval units, especially aircraft carriers. These vessels' erratic high-speed motions make them hard to target. Being able to quickly change direction and maneuver increases the ship's defenses and minimizes its torpedo and anti-ship missile vulnerability. Navy ships can navigate bad weather with high-speed rotations. Storms, waves, and rough seas can endanger ships and crew. High-speed movements allow ships like the USS Gerald R Ford to quickly adapt to adverse weather and minimize damage. These moves improve the crew's agility in rough seas and lessen the ship's operational capabilities and volatility. High-speed spins provide operational flexibility and preparedness beyond tactical evasion and weather avoidance. Naval boats must be agile to adapt to changing conditions, threats, and opportunities in volatile and controversial regions. High-speed rotations might change ship positioning, mission aims, and tactics. The vessel's reactivity and agility determine mission success in many operational conditions. High-speed turns are spectacular and crucial to strategy and operations. These moves allow ships like the USS Gerald R Ford to bolster their defenses, safely transit perilous surroundings, and maintain operational flexibility in contested and shifting zones. High-speed spins are essential for naval combat success and domination. 3. Starting rapid turns. Engineering precision. Fast turns need careful planning, engineering, and organization, especially for a huge ship like the USS Gerald R Ford. Aircraft carriers are too heavy and large for dynamic movements. Discover the complex steps needed to start high-speed turns and the amazing engineering that makes them feasible. From the bridge captain to the engine room mechanics, the carrier's crew must work together for a high-speed maneuver. The carrier's complex communication system relays the captain's orders. This command starts a strict sequence of steps to move. The carrier's propulsion system facilitates fast rotations. The USS Gerald R Ford's nuclear reactors generate unmatched thrust and acceleration. Carrier's engineers improve power by modifying control systems to the captain's high-speed turn commands. Engine room crews monitor carrier hull temperature, pressure, and other important factors to improve propulsion systems. Turbines quickly convert the carrier's nuclear reactors' massive power. These professionals examine all systems during high-speed maneuvers to keep the carrier stable. Carrier rudders are needed to steer and maneuver the ship at high speeds. A fine-tuned rudder guides the ship into the turn at high speed. Advanced control systems and navigation aids calculate optimal movement parameters using sensor inputs. The ship's propeller shafts and propulsion system convert energy into motion. These components must be made of durable materials to endure high-speed movements, massive stresses, and forces. The U.S. Gerald R Ford can spin at high speeds thanks to its precision engineering and crew work. The maneuver is carefully planned to ensure efficiency, efficacy, and safety. From the commanding officer's orders to the engine room's vital metrics verification, modern control, navigation, and propulsion technologies make the U.S. Gerald R Ford a naval warfare technical marvel. 4. Rudder Extreme Test. Maneuverability limits. Rudder system maneuverability and reactivity are vital in naval engineering. The severe rudder test tests a ship's rudder in extreme conditions and challenges its maneuverability. Discuss how this exam affects operational readiness. A ship fails the extreme rudder test if it can't handle dangerous maritime conditions. Naval engineers and operators test the rudder's reactivity, dependability, and seaworthiness under harsh conditions. In emergencies or evasive movements, the extreme rudder test tests the ship's steering capacity. Rudders are necessary for safe and successful steering if the ship must make a sudden course correction to avoid a threat. Naval engineers can evaluate the rudder's responsiveness and reliability to make precise course changes quickly by drawing it to its maximum angle and simulating high-stress circumstances. The extreme rudder test measures a ship's stability and handling in rough conditions. Every weather requires ships to be ready to sail. Simulating difficult scenarios and putting the rudder through extreme angles and operating conditions tests the ship's control and stability in bad weather. This examination is essential for naval warships to perform well in various deployment circumstances. The extreme rudder test is significant for ship design and technical evaluation. Aircraft carriers like the U.S. Gerald R Ford use advanced technology and complex systems to maximize efficiency and performance. Naval experts evaluate the ship's propulsion, steering, and design strength by testing the rudder under harsh conditions. Navy vessel designers can improve future vessels with this information, providing them an edge in maritime operations. The extreme rudder test pushes engineering and technology to achieve operational readiness in dynamic and difficult maritime situations. The test assesses ship maneuverability and seaworthiness. Engineers can evaluate the rudder's reactivity, reliability, and efficacy in extreme conditions and simulated high-stress scenarios to help naval boats navigate a variety of obstacles. 5. Technology and crew training for high-stress situations. All U.S. Gerald R Ford high-speed maneuvers require crew training and technology precautions. The U.S. Gerald R Ford crew handles high-stakes situations easily and accurately because of modern technology and extensive training. Crew training is essential for U.S. Gerald R Ford operations. The ship's crew trains systematically from the flight deck to the engine rooms to respond quickly to movements. These exercises simulate high-speed movements and other severe scenarios to evaluate the crew's readiness and adaptability. On the flight deck, pilots practice precision maneuvers for takeoff and landing. These workouts improve aircraft control, deck operations, and coordination during tight maneuvers. The carrier's propulsion engine rooms are stressed during high-speed movements. Technicians monitor gauges, make real-time adjustments, and work together to keep the carrier's propulsion system running smoothly in bad weather. Crew training is only part of it. Modern technology prevents ship overloads and blackouts on the U.S. Gerald R Ford. These protections, cleverly integrated from the bridge to the engine rooms, use cutting-edge technology to measure stress levels and control acceleration to keep the crew and carrier safe during dynamic moves. Bridge controls allow the captain and navigation team to make precise turns. The carrier navigates high-stress situations confidently and accurately with complex navigation technologies that calculate turn parameters from sensor inputs. The vessel can operate safely and effectively in unpredictable and risky marine settings. The U.S. Gerald R Ford uses this human technological mix to improve naval capabilities. 6. Revolutionizing naval technology. Future vision. A new naval warfare period brings new naval technologies that will change maritime supremacy. AI-assisted navigation systems and better propulsion technology will give naval combat new strategic advantages. Discover how new technologies will alter the tactical capabilities of massive warships like the U.S. Gerald R Ford. AI and autonomous systems in marine technology seem promising. High-powered technology can instantaneously detect environmental parameters and fine-tune route alterations for efficiency and safety, making Navy vessel navigation easier than ever. AI algorithms improve situational awareness and operational efficiency, helping ships like the USS Gerald R Ford to navigate dangerous waters with precision and agility. Propulsion system upgrades may boost naval warship speed, range, and maneuverability. Advanced nuclear reactors, hydrogen, and biofuels will power sustainable and innovative propulsion. These improvements will improve the operational capabilities of ships like the USS Gerald R Ford and help the maritime industry reduce its environmental impact. Data analytics and improved sensor systems will allow naval boats to collect, evaluate, and use data differently. Naval technologies like radar, UAVs, and underwater drones will improve situational awareness and intelligence gathering. Big data and predictive analytics help ships like the USS Gerald R Ford anticipate threats, optimize operations planning, and more in contested and unpredictable environments. Materials research and engineering have made Navy warships lighter, stronger, and longer-lasting. Improved composite materials and nanotechnology-enabled coatings aim to increase naval vessel performance and reduce maintenance and life cycle expenses. These cutting-edge materials allow naval engineers to improve the operational capabilities and performance of boats like the USS Gerald R Ford, ensuring readiness and resilience in the face of changing threats and challenges. Artificial intelligence, autonomous systems, improved propulsion, and sensors are shaping naval battles. These advanced technologies will change maritime supremacy tactics, allowing naval forces to be prepared, nimble, and dominant in a changing environment. Ships like the USS Gerald R Ford will also improve naval capabilities. The future of nautical technology is endless, and maritime genius will remain. Our tour of high-speed exercises on the USS Gerald R Ford shows that human expertise and cutting-edge technology are always pushing naval battles into new territory. Come seek the waters with us for an end to creation's endless possibilities. Wishing you winds and waves until we meet again.